So, what I'm going to be talking about fits very well with the overall topic of the conference, which has been AI so far, and or AI heavy, let's put it like that. And others have mentioned like visual testing, and also testing versus checking is an interesting discussion. And I'm tapping on all of that. My goal today, how many of you have a GitHub has a GitHub account? Anybody has a GitHub account? Okay, so my goal today is that you go and star us on GitHub. Because I'm going to show, and talk about an approach that's a whole different approach to probably what you've seen so far, and a tool that you can use that is open source, and yeah, please star us on GitHub. So, I don't know if you ever had that. A typical test, you define what you want in terms of an assertion, that if you think about an umbrella, it could like this, like if the umbrella opens, the test should pass, right? And then that happens. So the umbrella does open, the test passes, but overall it's not quite the experience that you would like your user or your customer to have. And for that, I'm going to show you just a quick demo. So who of you has ever used Selenium for test automation? Okay, so this is a typical Selenium test, as you can see. I just will have it execute. And what it does is, for a very basic application, it enters username, password, logs in, and then via an assertion, it checks whether success is displayed on the resulting page. And if you now go and change the CSS, which means that the application from a user's perspective is essentially broken, right? If your website looks like this, it's not good, but the test passes, because all the test checks is whether after login you display success. However, if you do, let's revert that, if you change the ID, no user cares about the ID of your elements because he doesn't even see them. But if you change the ID of the test, well, guess what? The test will fail because it doesn't know how to find the element it wants to interact with. And that's not good. But this is basically the state of the art in test automation. And we want to change that. So we have created this open source tool that you can use. And all you have to do is you wrap your driver into a recheck driver, and you delete the assertion. And then if you execute the test and change the CSS again, so live demo, hope it works. Now you see the website is broken, and this time the test fails. The test says, oh look, there are 116 differences on the website. You should have a look at that, if it's correct or not. And if you go and do the other thing and change the ID or delete it, and as you can see, it's the same test, right? What it does is it uses the ID to identify the element it wants to interact with. And now the ID on the live website is gone. If you execute the test, it can still find the element it wants to interact with, it executes the test, and the test passes. And this is no fake, this works like that, and I'm going to explain to you how it does it. So, I hope you're now with me. So the basic idea is to do one thing different. Instead of defining the outcome in terms of an assertion, you approve it. So you say, okay, I've executed the test once, I see what I get, this is what I get, I want that, now make sure the next time is the same thing. And the basic idea behind it is that automated testing is not testing. Let me repeat that. In my opinion, automated testing is not testing. Because when you manually test a software, you want to find defects. When you execute an automated test on your software, you don't want to find defects that are already there. With your test, with your automated test, with your regression test, all you do is you guard against introducing new defects. So in that regard, it's version control. You want to version control the software in its behavior. And we have a thing for that. It's called Git or SVN, or we have systems that do that. However, the version control systems they control the code. So they tell you if the code has changed. But the problem is, software is more than code, right? You just saw there's code, but the software that the user experiences has runtime execution, has configuration, has data, has so much more that is not under version control, meaning that the user experience is not only defined by the code, but the code is only the thing that is managed by version control currently. And this currently is kept, so what we want to know, as I said, is how does the software change, and we bridge this gap by testing. So an automated test, viewing it like that, is just a means to turn the behavior of the software into a static artifact that you then can manage with version control. However, the way we do this right now with assertions, we do this very poorly. It's like a crutch. It doesn't work. So we can do better, and this is what we did. If we say automated tests are version control, then what we want to use is golden master-based testing. And this has two challenges. It has a lot of noise and a lot of redundancy. And I'm going to tell you how we address that. So noise essentially means, imagine you had Git without the Git ignore file. It would show you every file is being changed, right? Like the class files, the log files, everything. So what we need is, we need to have the Git ignore. And if you think about that, if you do it with testing, when you have an assertion, essentially what you do is you deny a change. You say, this specific attribute cannot change without the test telling me so. If you have an ignore list, on the other hand, like with a version control file, a Git ignore file, you're telling, OK, I don't care about that change. Whenever the log file changes, just let it be. I don't care. And the extremes are, on the one hand side, you could check everything. You could say, oh, just, I don't have a Git ignore file. I want to see every change. And on the other extreme, if you have no assertions in your tests, then you basically check nothing other than the test can still execute, right? And the good thing, the thing that you want is somewhere in the middle. So you don't want to check everything, but you don't want to check nothing. So, you want to be somewhere in the middle. And now is the question, how do you approach that middle ground? How do you get there? Do you, create a lot of assertions, or do you, ignore things that you don't care about? And there's an interesting anecdote. With Google, apparently, they have this, dancing pony on the screen that they put to mark changed controls for testers. So if you're a tester at Google, and you see that dancing pony, OK, that thing has been changed. It has been touched by development. So I need to very, intensely test that thing. However, at some point, the people forgot to remove the marks. So suddenly, the customers had dancing ponies on their screen because no one coded a test for that. So the thing is, with an assertion, you need you only can create an assertion for what you actually expect. If something changes unexpectedly, you don't have an assertion for that, right? And this is a problem. So on which side do we want to err? This is also the reason why when you create a firewall, you create an ignore list. Like, this is the traffic that can go through, and not a deny list where you say, OK, close these ports. And in our experience, you most of the time want to ignore, you want to more check rather than less. So you have a couple of ignore rules, but you want to know about changes, essentially. So this approach is, in a way, what we call it, it's Git for the GUI. So it's a version control system of the behavior of the software. And just like Git has a Git ignore file, we have the recheck ignore file where they can very detailed specify what you're not interested in. So you can say you want to ignore the class attribute globally for every element. You want to ignore specific elements. Or you can mix and max. You can combine and say, I want to ignore the font or anything related to font for that specific element, whatever. So you can just mix and match. And we also, I have a demo for that. So this is our GUI, by the way. This is a part of the commercial product, but it's very visual, so I put it here. So these two websites, as you can see, they are very different. Like this one is completely like white and blue, and this one is green and different fonts, and these are very different. But you can say, okay, I don't care about positioning. I don't care about style. So whenever color and font and whatever changes, I don't care about that. And you can say, I don't care about the class and ID and the internal stuff, so ignore all of that. And then you see where the website has actually changed. And you can do that, you can use the same mechanisms in your ignore file. So you can say, I don't care about any of the CSS, just show me where the contents changed, or vice versa. So you can, use it as you like. So, yeah. We've heard about pixel diffing before, and the problem with pixel diffing is you have to have heuristics, or you have to, like if you do a draw, you get a lot of differences that don't matter to you. And if you have a change that's as big as that, yeah, that was a demo, then you get a lot of false positives. And using those filters, you can just ignore what you don't care about. And it even works with animations. Like, how do you pixel diff an animation on your website? If you have a CSS animation or anything, it doesn't work anymore. But with that, you get reported the attribute differences. So it tells you that, for instance, the animation starts 3 seconds later or has a delay or whatever. The second problem with golden master testing is redundancy. So you don't create just one golden master for a website. If you have like 1,000 tests, you have probably 1,000 golden masters. And if you then check, say, the logo of the website, you have 1,000 failing tests, right? Which you would normally have to have manually adapt or approve. And to fix that problem, or to help you with that problem, we created both an open source CLI, like Git has a CLI. So you can just say, okay, whatever the change, or using filters, you can say specific changes. Please apply all of them through all of my 1,000 tests. So this is one command to maintain all of the golden masters. And using the GUI, the commercial GUI, you can do the same, just using those checkboxes and say, okay, apply those changes. Now for the cool feature that you saw before, like usual problem is that something on the website changes and then your test fails, right? Because you can't find the ID anymore. Like you use the ID to identify the element you want to interact with, and those change. Well, the cool thing is, what a golden master is essentially a copy of the website. So if the ID changed, well, guess what? I still have the copy of the website where the ID is there, the old version of the ID. So I can go into the copy, find my element that I want to interact with, then go to the current version of the website and find the element that has the closest match, like that's the most overlap in terms of name, text, XPath, class, whatever, all the other attributes. So you match them and find the highest match, and then just return that to Selenium, and Selenium uses that, and the test continues. So the test doesn't break. And we even tell you, so in the log file, we can say, oh, look, this ID has changed, and if you now update the golden master, like if you use the CLI, as I just showed you, and apply the change to the golden master, then will your test fail. But you get notified beforehand, and currently what we're working on, what is not yet implemented, but we're working on, is that you can auto-heal the test. Using that information, you can go and update the code of the test automatically and insert the new ID, or if there's no ID, you can even go one step further and use a retest ID. Now, what's a retest ID? Well, the basic idea is we create a copy of the website, as I just said, with the golden master. Now, we can go and insert additional attributes into that copy of the website. And because those attributes only live in the copy, not on the live site, they can never be affected by change. So however you change the website, if some developer comes and changes the ID for whatever reason or deletes it, the test can still execute fine because that attribute doesn't live on the website. It's only inside the copy. So nobody can affect that except for you, except if you want, like manually, want to apply any change to it. And using that, it's the same idea. So we find the ID in the current version of the Golden Master. We do the one-on-one assignment to the current version of the website. We find the highest match, and we use just that. But with the retest ID, you're independent. It's a constant virtual identifier with which you're independent of the actual website. And you can use that inside your test automation. It's a drop-in replacement. And it helps you even with stuff like that. Like if you have problems identifying the elements that you want to interact with because they don't have an ID, well, guess what? You don't need a complex XPath expression anymore or a complex CSS selector. You can just use the retest ID because every element has a retest ID in the Golden Master. So you can just use that and get rid of that problem. So right now, what's not very good, which we are still working on, is how you retrieve the retest ID, because it's the Golden Master essentially is an XML file, a large XML file. So you have to go into the XML, find the retest ID there, and use that. But we're working on that too. As I said, the next version will auto-apply the changes to the test code. So what you can do is essentially, I don't like the term, but it works, codeless automation. I mean, no automation is ever codeless because it executes on a computer, but you know what I mean. So you can just record the test, create the Java Selenium file, then if any change occurs, because you don't need to code an assertion anymore, right? It's just a recording of the user. You don't need anything else. You just record what happens, create a Java file, execute it, have the Golden Masters created. If something changes, we just apply the retest ID, and you're good to go. So you don't have to touch the Java code of the test anymore with that approach. And another thing that one of our customers realized is you get the possibility to create data-independent tests. Because what they did is, essentially, they get, like every week, they get 10% of the production data into the test database to have the most current data to work with. And so all the tests fail constantly because the customers change, the data in the database changes. You don't know how to put an assertion in there. Like, what do you assert for if the data changes, right? You essentially have to recreate the functionality of how the data should look like. So what he does is now he creates tests that click on like the first customer, whatever the customer name is, or clicks on the first table entry or the first whatever, and just clicks through the application, and then whenever new data comes in, you throw away the Golden Master, you create the Golden Master, then you throw away the code and use a new version of the code, and then you see where the changes are. So in that way, you can now create data-independent tests. So to summarize, recheck gives you a rule-based deterministic ignore. So actually, you can ignore stuff without having to rely on AI. So you don't need to train AI to say, ignore that change, that constant change. You can just define a rule for it. It's open source. You can just go and use it. Right now, it's implemented for Java, Selenium Java, and we're working on the JavaScript implementation, also for Cypress and other testing tools that you were working with. You can use it offline because the Golden Master is created offline. So you can just store it and commit it to your version control system. It gives you the possibility to create unbreakable, like virtually unbreakable Selenium test. Unless the button isn't there anymore, we will find it. And in principle, it doesn't even, it does work with any technical interface. So I showed how it works with GUIs, but you can do the same with XML files, with JSON files, with any interface that you have for your systems. Like if you have two systems that have to communicate with each other, you can use that Golden Master approach. And also recheck, although we only have implemented it for GUIs. People so far like it, people that have tried it think it's very helpful. And you can even use it for manual testing. Like it's a Chrome extension, so if you do manual testing in your browser and you want to see the differences between two versions of the same website, it's a Chrome extension where you can just use it. So yeah, it's open source. Please use it. the business model behind the whole thing is that we give you the GUI. That costs a little bit. But the real cool thing is we're going to give you AI. Because AI has a big problem of whether, if 5 is the answer of your software, is this right or wrong? The AI doesn't know, usually. So what you now can do is you can just execute the software, see that the answer is 5, execute it after you made a code change, and see if the answer is the same. So as I said, it's version control of the behavior of the software. So we use that for using AI to create tests for your software. So thank you very much.
Thank you very much. We have loads of questions, so let's start with them. You can see them in just a few seconds on the screen. They are coming. Yes. No. Yes.
What if the code has been refactored and not just a parameter name? I'm not sure I understand the question correctly. So the code of the test has been refactored, or the code of the GUI? I think the GUI is meant. So in that case, you just have more changes. So we have a threshold. So if the overlap is at least you can configure that. But if the default is if the overlap of the elements is at least 70%, we assume it's the same element. So, but this is something that even humans have trouble with. So if you have, for instance, a button here and a button there, and this one disappears and this one appears, at one point do you assume it's the same button, right? So if you have a lot of changes, you just have a lot of changes, and we show all of them, and then at some point it might get difficult. I hope this answers the question. If not, please, do another one. Okay, next one. How do you identify the best match? So it's based, it's no visual matching. So we don't do pixel comparison. We do extract the complete, so all attributes of all elements of the rendered DOM. So we get the font, the text size, the text content, all of those stuff, and we can use them to assign every element to every other element of the old or the new website, and just return the one with the highest match. So next one, without assertion, how can you know whether behavior is proper or not? So that's the thing. You have to decide up front. So you just approve. So you test manually once. And then if you think this is a software you want, or this is a behavior that's correct, then you use that to automate. But you have to manually approve the behavior once, and we just make sure it doesn't change. We don't say it's correct. Is this solution, regarding API testing, automation tests are same as manual. How would you separate those two? I'm not sure I understand the question correctly. So, so when we do API testing, you usually also have an input and an output. And for the output, you want to verify that the output is the same, that it didn't change, or at least didn't change much. And you can use the same tool. So we have a proof of concept implementation for XML, where we show that it's working also for XML. And you can also use the same ignore mechanism. You can say ignore timestamp, ignore that part of the XML tree, whatever. And in that regard, we show you all the differences in the output, whatever the output is. I hope that answers that question. How do you prefer false positive matches over changed elements? How do you prevent false positive matches over changed elements? Well, as I said, we have this very powerful ignore mechanism where you can just define what you want to see or what you don't want to see, what you don't care about, and these changes are not reported anymore, so the test doesn't fail. Like with the demo that I made, the ID changed, but the test was still green because I had defined that I don't care about the ID, so ignore the ID change and make the test pass. So that's essentially what happens. Is this solution works for native mobile apps? Unfortunately, not yet. So the general approach works, as I said, for any interface, even like GUI interface or technical interface, but we started implementing it for Java, Selenium, web tests. So for now, this is what we focus on, and we will go from there and implement it for other languages and other frameworks like Cypress and others, and then maybe eventually get to mobile. But so we have it on our roadmap, but it's nothing coming like in the next couple of months. If automated test is just for version control, how would you explain the case when automated test generation is used from a model, but with some randomity? So the thing is that essentially you have the code, and you have one code base, but using infinite many different data points, you can come up with the same code with indefinite many different versions of the program, right? You can, using configuration parameters and whatever, you can just have like gazillions of versions of the executed software. So you just need to focus. You just need to select on some. So if you have the very simple application of 1 plus 1, or sorry, A plus B, and you pick A and B, you can have indefinite many different test cases for that. So you just have to pick which are relevant for you. And you can use AI to do that. Like you can say, okay, give me the test cases with the most risk, or give me the test cases that in the past found the most defects, stuff like that. But at some point you have to pick, so you can't execute all of them. How do you decide whether the change, for example, sign-in or sign-in, is used by purpose or by mistake? Well, that's a human decision. That's where I think that after AI has taken over and is generating all the code and is generating all the tests, at some point, someone has to make the decision, right? So you have to have a human in the loop that decides what is it that we actually want. If we want a chat program, do we want WhatsApp or do we want Skype? If we want a photo sharing application, should it be Instagram or should it be something else? So at some point, someone has to decide what the result should be, and this is something that hopefully will take quite a while until AI can do that. So for now, this is what the human has to do.